Good morning, good afternoon, everyone. Welcome to our second online lesson. Today we will be talking about operations with algebraic vectors in R squared. We define algebraic vectors. We know what they are. Now, the next logical step is to do operations. Guess what kind of operations we're going to perform with these algebraic vectors? We will do exactly what we did with geometric vectors. We will do addition and we will do multiplication by a scalar. But in order to accomplish this, we need to define a very special type of vectors. We need to define unit vectors. Unit tells you that the magnitude of this vector is 1. And I'm going to place these vectors in a very special way. I'm going to place one of them along the x-axis. It seems like it's, so don't forget, magnitude must be 1. So that is one of my vectors, one of my unit vectors. Okay, now it's okay. I am going to call the vector, the unit vector along the x-axis, I. Vector I show it's a vector, and I'm going to write it as 1 and 0. Yes, as a position vector, I can write it as 1 and 0. And the same thing on the y-axis. Let's put the second unit vector on the y-axis. A little bit too long. Let's make it shorter. Okay, is it pretty good? Should be. Yeah, it's decent. My second vector, the one along the y-axis, I'm going to call it J. And as a position vector, the x-coordinate is 0, the y-coordinate is 1. So far, so good. Okay, now, why did I do that? Why did I introduce these two position vectors? I along x-axis 1 and 0, j along y-axis 0 and 1. Because from this point on, I will be able to represent any vector in R squared using these two vectors. What vector did I represent here? This is a position vector, OP, and OP can be written as, what's my x-coordinate? It's 4. What is my y-coordinate? Is 5. How can I write that using my unit vectors? Well, I can write this. I hope you don't mind if I write this vector as the addition of the following two very special vectors. One along the x-axis, this one over here, one along y-axis, or translate it a little bit, right there. Let's use a letter R here. So, not a surprise for you that the vector OP can be written as vector OR plus vector RP. Now, vector RP is not a position vector, but nothing stops me to use this vector. Let's call it OS. Okay, so instead I'm going to write OP as OR plus OS. Not a surprise, OS, RP are equal vectors, so not big deal. Good. Now, how can I write vector OP? Vector OP is OR, but OR is nothing else but 4 times what vector? The unit vector I. You remember our special vector along the x-axis. OR is nothing else but 4i. How about OS? OS is nothing else but 5 times 1, 2, 3, 4, yes, 5 times vector j. So there you go. I have two equivalent ways to write vector OP. I can write it as 4, 5, as I did here, or I can write it using unit vector as 4y plus 5j. Okay, let's see why did I need to go through all this trouble. The reason is I want to add vectors. What we have right here on the board, we have two vectors, vector OP, point P right there, vector OP, that is x coordinate is 4, the y coordinate is 1, and vector OR, that is OR, x coordinate is 3, I believe, yes, and the y coordinate is 5, 3 and 5. Now let's practice the way we wrote these vectors using unit vectors. What is the way to write this one? Well, it's nothing else but 4 times unit vector I plus 1 time unit vector j. How about OR is 3i plus 5j. We just learned that using our unit vectors, right? Unit vector here, I, unit vector here, j. Good. So yes, indeed, 4 reds here plus 1 green here, it's right, for OP, and for OR, 3 reds here and 5 greens over there. So yes, that's correct. Good. So now, how do I add them? I wanted to notice, I have here, I started for you, the parallelogram that I need to create. If you like the triangle rule, nothing stops you from using the triangle rule. So how do I just drew for you the resultant of the addition of OP and OR. Now let's take a look at the coordinates of OS. I have here a triangle which is nothing else but this triangle over here. And I want you to notice that that triangle is absolutely the same as this triangle over here, which means the length of this hypotenuse here, is 3, is nothing else but the x coordinate of R, right? Yes. So that means if that triangle is equal to that triangle, it means that the x coordinate of point S is nothing else but 4 plus the length of this base, which is 3. So on the coordinates, I can write OS as 4, this 4 plus 3, that base, 4 plus 3, and absolutely identical, I'm going to write the y coordinate of S as 1 plus, how much is the length of that side? Well, it's nothing else but the y coordinate. Oops, let's move the triangle where I want it. There you go. Here is nothing else but the y coordinate of R, which was 5, right? Oops, undo. Okay. There you go. I have too many things here. There you go. So the S, the y coordinate of point S is 1, this one over here, plus this 5 over here. 1 plus 5. Where did I get this 4 and 3? Well, let's take a look. 4 is this 4. 4 plus 3. There you go. How about 1 plus 5 is nothing else but that 5. So OS can be written as, OS can be written as using coordinates 7 and 6, or using unit vectors 7i plus 6j. Notice I could have used my unit vectors here. 4i plus 3i is my 7i, 1j plus 5j is my 6j. Please notice how easy it is to add vectors using the we don't need this anymore. Let's get rid of it. Using these new notations, using the algebraic representation of vectors. So all the trouble we've been through has a reason, and you will see. You will see more and more why we do that. Okay, so we don't need all of those on our diagram. Good. Addition of vectors. One more thing. Multiplying a vector by a scalar. Again in R2. I have here vector OP again. Let's see. OP is given as x coordinate is 4, y coordinate is 1. Using unit vectors is 4i plus 1j. What I want to multiply this vector by, let's say, 2. How much is 2 times OP? Well, first of all, let's graph it. How do I graph it? Well, I need to double these. So, there you go. I need 2 vectors OP. There you go, one and the second one. There you go. Second one over here. Okay, a little bit better. Good. What do you think are the coordinates of the new vector OR? Well, I don't think it's a big deal to notice that the x coordinate is doubled, the y coordinate is doubled again. As a result, the new vector 2AP is nothing else but 8 and 2. X coordinate, y coordinate using unit vectors is 8i plus 2j. There you go. That's a lesson for today. Enjoy. I'll see you soon.